Okay, so this second concept for the final exam would be connected to static equilibrium. And the best example for this is a ladder leaning up against a wall as shown in the diagram. So AD is the ladder, and the center of gravity of the ladder is at point B, which means that the weight of the ladder is acting vertically down through its center of gravity. And N1 is the normal force between the ladder and the ground. N2 is the normal force between the ladder and the wall on which it is leaning. In this example, we assume that the wall here is smooth, so there is no friction at that point. But at the ground, there is friction, and since friction is always opposite to the motion, it's going to be to the right, since the ladder has a tendency to slip to the left. And that happens when a person climbs up on the ladder. So this person is trying to climb up the ladder, and the question is, how far up the ladder can this person climb before the ladder begins to slip? So that's the question. Again, how far up the ladder can the person climb before the ladder begins to slip? In this example, we assume that this person can climb up to the point C, and that's why the weight of the person is shown vertically down, acting through the point C. So the weight of the person is, the weight of the ladder is 20 kilogram, and the weight of the person is 70 kilogram. The coefficient of static friction between the ladder and the ground at this point is 0.3. Given all that data, let's try to calculate the maximum distance AC to which this person can climb. N1 is equal to WL plus WP. Why? Because there are two conditions for static equilibrium. The first condition is that the net forces must cancel out. The net force must be zero. So considering the forces along the y-axis, you have N1 acting up along the y-axis, and you have WL and WP acting down along the y-axis. Therefore, N1 should be equal to WL plus WP. Similarly, on the x-axis, you only have two forces. One is friction acting to the right, and the other is N2 acting to the left. So obviously, they must be equal to each other. Because again, the net force along all three axes must be zero. In this case, we need not consider the z-axis. So the net force along the x and the y-axis must be zero. We've already written that for the y-axis. Now let's write it for the x-axis. Friction, we know, should be equal to N2. F1 is equal to N2. And then the second condition for static equilibrium is that the net torque must be zero. But whenever we calculate the torque, we have to pick a point. So in this case, we're going to calculate the torque about point A. Now, why is that important? That's important because now we're going to measure all distances from the point A. And all of those distances must be perpendicular distances between the force and the point. So for example, when you calculate the distance between WL and that point, we have to take the distance AE because that's the perpendicular distance. See that? Similarly, when you consider the distance between this force WP and the point, we have to consider the distance AF because that is the perpendicular distance. So when we calculate torque, we have to pick a point. That's step number one. And step number 2, we have to measure the perpendicular distances from that point to the line of action of the force. So calculating torques about A, we find that WL and WP are both trying to turn it clockwise. Okay? While N2 is trying to turn it counterclockwise. There is no torque due to N1 and F, for the simple reason that these two forces are acting right at that point, and so there is no distance from that point for these two forces. So we only have 3 forces creating a torque at the point A. 2 of them are clockwise and 1 is counterclockwise. Therefore, WL times AE plus WP times AF should be equal to N2 times DG. Now why DG? Because DG is the perpendicular distance between the line of action of the force. Now watch this carefully. That's the line of action of the force. This is the point. So that's the perpendicular distance, right? That is the line of action of the force. That's the point. So that's the perpendicular distance. And that is exactly the same as DG. So now we have to set up some ratios, because if you look at what's given, the length of the ladder is given as 6 meters. The center of gravity of the ladder is said to be 2 meters away from the ladder. So AB is 2 meters. And AG is 3 meters. That means the foot of the ladder is given to be 3 meters away from the wall. So these 3 distances are given. And remember, we're trying to find AC. So we have to now represent AE in terms of the given distance AB. AE in terms of AB, that's easy because you have a triangle here, you have another triangle here, and you have a third triangle here, right? So these are similar triangles and we can take the ratio of the sides. So AE by AG. So the ratio of AE by AG should be equal to AB by AD. That's the idea. AB by AD. AB by AD is 2 by 6. You can see it's 2 by 6. And AG is 3. So 3 times 2 by 6 gives you 1 meter for AE. And then friction is mu times N. Friction is the product of coefficient of friction and the normal reaction. And from there, we also know that N1 is 20 plus 70 times 9.8, because we have N1 as WL plus WP. Those are in kilograms. So when you multiply it with 9.8, you get the normal force in newtons. So that's what I've done, 20 plus 70 times 9.8 to get the normal reaction in newtons. Once you get that, we can find the friction. 0.3 times 882. That gives 264.6 newtons. That is friction. Once we know friction, we also know the value of N2, because F1 is exactly the same as N2. So 20 times 9.8 times 1, I'm substituting into this, 20 times 9.8, the weight of the ladder is 20 kilograms, so it's 20 times 9.8 into 1, because we got AE as 1, plus the weight of the person is 70 kilograms, so 70 times 9.8 into AF, which we do not know. So we do not know AF. So that's equal to 264.6 times 5.2. So DG is 5.2. Now DG is 5.2 from this right angle triangle because you're given AD and AG. Okay, so that's how we get 5.2. Here, DG is square root of 6 squared minus 3a squared, which gives you 5.2 meters simply by taking the squares of the sides and adding them to get the square of the hypotenuse. Okay. So now doing the math, 20 times 9.8 is 196. 70 times 9.8 is 686. We do not know AF. And here on the right side, 1375.9, from which we can get AF. Once you get AF, we can calculate AC. AF by AG is equal to AC by AD, from which we can find AC. So rearranging, AC is AF by AG times AD. Okay, so that's 1.72 times 6 by 3, which is 3.44 meter. Remember, we got AF here as 1.72. AG is given us 3 meter. AD is given us 6 meter. So the person can climb up to a distance of 3.44 meters before the ladder begins to slip out. I hope you understood how to apply the conditions for static equilibrium in solving this question. Remember, understanding this question is key, because if you understand it completely, you can apply these conditions to any situation and solve for the unknown. I hope this helps. Let me know. Thank you.